You're not aging, you're rusting. And the difference between those two things? It's everything. Because rust can be reversed. I know what you might be thinking right now. That's just what happens. You get older, your body breaks down, and that's the deal. And you know what? Until about 5 years ago, most scientists agreed with you. But they don't anymore. Every protocol in this channel is reviewed by a clinical pharmacist and researcher. Because what I'm about to share with you isn't opinion. It's biology. And biology, unlike birthdays, can be negotiated. Here's what nobody tells you. By the time most people hit 40, they've already lost up to 25% of their collagen. Not just the stuff that keeps your face looking young, but the architecture that holds your joints, your vessels, your entire body together, from the inside out, and the thing silently accelerating that collapse. You're probably doing some of them right now. Not out of ignorance, just out of habit. So today, we're going to change that. Let me paint you a picture. Imagine a bridge, a well-engineered, beautifully constructed bridge. For years, it handles the weight of traffic, weather, the relentless push and pull of daily stress. And for a while, it holds up perfectly. But underneath the surface, in the cables, the beams, the joints, tiny fractures are forming. Invisible to the eye, imperceptible to anyone just driving over it. And then one day, something gives. That bridge is your body. And the cables holding everything together, that's your collagen. Most people, when they think about aging, think about what they see in the mirror. The lines around the eyes, the skin that doesn't quite bounce back the way it used to. Maybe the stiffness in the morning that takes a few extra minutes to shake off. And so they go looking for solutions in the mirror too. Creams, serums, expensive treatments that sit on the surface and do very little about what's actually happening underneath. But here's what the science is telling us with increasing clarity. The aging you see on the outside is a direct reflection of what's happening on the inside. Your skin isn't just getting older. Your fascia, the connective tissue that literally wraps around every single muscle, every organ, every structure in your body, is stiffening, losing elasticity, losing its ability to communicate, to move, to repair. And collagen is at the center of all of it. Now, collagen isn't just a beauty ingredient they put in face creams to sell to people who are afraid of wrinkles. It is the most abundant protein in the human body. It makes up about 30% of your total protein content. It's in your skin, yes, but it's also in your tendons, your ligaments, your cartilage, your blood vessels, your gut lining, and even your corneas. It is, in a very literal sense, the fabric of you. And when that fabric starts to fray, things break down fast. Here's what happens structurally. As collagen degrades, the fascia loses its fluid, supple quality and begins to harden. This is why many people over 40 start to notice that their posture changes. They begin to round forward slightly, the shoulders drift inward, the neck pushes forward. It doesn't happen overnight. It happens millimeter by millimeter, year by year, as the scaffolding quietly gives way. And this isn't just cosmetic. This matters for how you breathe, how your organs sit in your body, how your blood flows, how your nerves communicate. A stiffened fascia isn't just uncomfortable, it's a system under stress. Now here's where it gets interesting. And this is the part most people never hear because most conversations about aging stop at take this supplement or try this cream. There is a specific enzyme in your body whose job is to break down collagen. It exists for good reason. Your body needs to recycle old collagen and replace it with new fibers. That's a healthy, normal process. The problem begins when this enzyme becomes overactive, when the breakdown outpaces the rebuilding. And there are very specific, very common things in modern life that trigger exactly that. Certain antibiotics can do it. Excessive, unprotected exposure to ultraviolet radiation accelerates it. Chronic stress floods your body with cortisol, which signals the body to prioritize survival over repair. And collagen production is one of the first things to get deprioritized. Poor sleep compounds everything. And then there's the biggest, most pervasive trigger of all, the one hiding in plain sight on almost every grocery store shelf. Sugar. Not just the obvious kind. Not just the white crystals you might put in your coffee. I'm talking about a process called glycation. When excess glucose circulates in your bloodstream, it binds to proteins, including collagen, in a process that essentially caramelizes and stiffens them. It locks them up, makes them rigid, brittle, non-functional. Scientists even have a term for these damaged structures: advanced glycation end products, AGEs. The acronym is not accidental. And here's what makes this particularly tricky. Most people who think they're avoiding sugar aren't. They've learned to read labels. They see ZOG sugar and feel safe. But what they're missing is the starch. Specifically, ultra-processed starches like maltodextrin and modified food starch, which are nothing more than long chains of glucose molecules that your body disassembles and absorbs with terrifying efficiency, faster than table sugar in many cases. So your body is quietly drowning in glucose, and you think you're being careful. This is the invisible accelerant. This is the thing that's aging you faster than almost anything else, and it's sitting in the protein bars, the low-fat yogurts, the packaged snacks that carry health halos and say nothing honest on their labels. Understanding this, truly understanding it, changes the way you look at your plate. It changes the way you look at your morning routine. And it changes fundamentally what taking care of yourself actually means past 40. Because the goal isn't just to look younger. The goal is to function better, to feel more capable, more resilient, more alive, not just in how you appear to others, but in how you experience your own body from the inside. That is what we're building toward in this conversation. Let's talk about what your body actually needs to rebuild. Because here's the thing about collagen that most people don't realize. Your body doesn't absorb collagen directly from food or supplements and then magically deposit it where it's needed. It doesn't work like that. What your body does is take raw materials, specific vitamins, minerals, amino acids, and then manufactures collagen on its own, inside your cells, through a tightly regulated biological process. Which means that if you're missing even one critical piece of that puzzle, the entire production line slows down, or stops. Think of it like building a house. You can have the best architect in the world, a motivated construction crew, and a perfect blueprint. But if someone forgot to deliver the lumber, nothing gets built. The body is no different. And most people over 40, even the ones who eat reasonably well and exercise consistently, are walking around with significant gaps in this nutritional supply chain. Let's go through them. And I mean really go through them. Not just a list of names, but why each one matters, where it fits into the process, and what happens when you don't have enough of it. Vitamin C. This is the one most people have heard of. And yes, it's essential, but not in the vague, general good for immunity way that you see on orange juice cartons. Vitamin C is a direct cofactor in the enzymatic process that stabilizes collagen fibers. Without adequate vitamin C, the collagen your body produces is structurally weak. It can't form the tight cross-linked triple helix structure that gives healthy connective tissue its tensile strength. This is literally the biochemistry behind scurvy, the disease that killed sailors for centuries, the one where their bodies essentially fell apart because their collagen couldn't hold together anymore. You don't need to be sailing the Atlantic without fresh food to be mildly deficient. Smoking depletes vitamin C aggressively. So does a high-sugar diet. Glucose and vitamin C compete for the same cellular transport system, meaning when blood sugar is elevated, vitamin C absorption is directly suppressed. The two biggest collagen-destroying habits in modern life also happen to be the two biggest vitamin C blockers. Where do you get it? The conventional answer is citrus fruit. But here's something genuinely surprising. Raw sauerkraut, fermented cabbage, contains roughly 10 times the recommended daily amount of vitamin C per cup. And it delivers it in a form that's highly bioavailable and comes packaged with powerful probiotics that support gut health. That's a combination that almost no supplement can replicate. Vitamin D3. Most people know vitamin D is important for bones. Few realize it plays a direct protective role in collagen preservation. Specifically, that it helps suppress the enzyme responsible for breaking collagen down. At adequate levels, vitamin D functions almost like a brake on the degradation process, slowing the rate at which your connective tissue is dismantled. Research suggests that 10,000 IUs of D3 daily is appropriate for many adults, particularly those living in northern latitudes, working indoors, or with darker skin tones that reduce cutaneous synthesis. This is not a number you'll typically see on supplement bottles, because it exceeds the conservative official guidelines. But the clinical evidence for higher therapeutic doses is substantial, and the risk of toxicity at this level, when taken without excessive calcium supplementation, is extremely low in healthy individuals. Vitamin K2. This one is far less talked about, and that's a mistake. Vitamin K2 is essential for the proper function of proteins involved in maintaining cartilage, ligaments, tendons, and skin. Without K2, calcium tends to deposit in soft tissues, including arterial walls, rather than being directed toward bones and structural proteins where it belongs. K2 essentially acts as a traffic director for calcium in the body. It keeps things where they should be and out of where they shouldn't be. You find it primarily in liver, egg yolks, and high-quality butter from grass-fed animals, foods that have been systematically demonized over the past few decades, often replaced in people's diets by processed alternatives that contain none of these benefits. Magnesium. Here is where things get layered in a way most people never appreciate. Magnesium is involved in over 300 enzymatic reactions in the human body. It is, in every meaningful sense, the most foundational mineral in human biochemistry. And in the context of collagen, it plays two distinct roles. It directly supports collagen synthesis, and it activates vitamin D. Without sufficient magnesium, the vitamin D you take, even at high doses, cannot be properly converted into its active form. You could be supplementing D3 religiously for years and still not getting the full benefit, simply because your magnesium levels are too low. Magnesium deficiency is extraordinarily common in developed nations. The soil is depleted, the food processing destroys what little remains, and chronic stress burns through magnesium at an accelerated rate, which means that the people who need it most, the busy, high-performing, perpetually overstimulated adults in their 40s and 50s, are often the most deficient. Dark chocolate, almonds, and leafy greens like spinach are your best dietary sources. A quality magnesium glycinate or malate supplement taken in the evening has the additional benefit of supporting deep restorative sleep. Zinc. Zinc is critical for skin cell renewal and wound healing. It plays a direct role in the synthesis of collagen and in regulating the enzymes that break it down. Zinc deficiency shows up on the skin, in poor healing, in texture changes, in a general loss of vitality that people often attribute to just getting older. Oysters are the single richest dietary source of zinc by a significant margin. Red meat and liver follow. If you're relying on plant-based sources alone, absorption is significantly limited by phytic acid, which binds to zinc and prevents uptake. Copper. Copper is the final piece of this particular puzzle. It's required for an enzyme called lysyl oxidase, which cross-links collagen and elastin fibers, the process that gives connective tissue its strength and resilience. Without copper, that cross-linking fails, and the structural integrity of the collagen matrix collapses. Oysters again are an excellent source. So is dark chocolate, liver, shellfish, and red meat. Notice something? The foods that appear repeatedly on this list, liver, oysters, red meat, egg yolks, dark chocolate, are not the foods that have been celebrated in mainstream nutritional guidance over the past 30 years. In fact, they're often the ones that were explicitly discouraged. And yet they are precisely the foods that provide the densest concentration of the nutrients required to maintain the structural integrity of the human body as it ages. That's not a coincidence. And it's worth sitting with. Bloco 4. Movement as medicine. How exercise rebuilds you from the inside. There's a conversation I want you to have with yourself right now. An honest one. When was the last time you moved your body in a way that actually challenged it? Not just walked to the car, or climbed a flight of stairs, or stretched briefly before bed. I mean genuinely, intentionally challenged it, loaded it, stressed it in a controlled way, asked it to do something slightly harder than it did the day before. If the answer makes you uncomfortable, good. Discomfort is the beginning of honesty, and honesty is where change actually starts. Because here's something the science is absolutely unambiguous about. The single most potent stimulus for collagen production in the human body is mechanical load. Movement, tension, the deliberate application of stress to tissue, not supplements, not serums, not any protocol you can buy in a bottle. Movement. When you place mechanical stress on connective tissue, tendons, ligaments, fascia, the cells that produce collagen, called fibroblasts, receive a direct biochemical signal to upregulate production. They respond to tension the way a muscle responds to resistance, by rebuilding stronger than before. This is not metaphor. This is cellular biology. Your body interprets physical demand as a reason to invest in structural repair. Sedentary living, on the other hand, sends the opposite signal. A quiet, persistent message that says, we don't need this infrastructure anymore. And the body, always efficient, begins to dismantle it. This is why people who stop moving age faster. Not just cardiovascularly, not just metabolically, structurally. Their joints stiffen, their posture collapses, their tendons become fragile. The architecture of the body quietly dismantles itself when it receives no reason to maintain it. But here's where it gets nuanced. And this is important, especially if you're over 40. The kind of movement that best stimulates collagen production is not the same as the kind that was ideal in your 20s. High-impact, high-repetition training can be effective, but it carries increasing joint risk as we age. The smarter approach, the one that actually aligns with how connective tissue responds to stress, involves specific types of loading that generate maximum collagen stimulus with minimum joint wear. The first is isometric training. This means holding a position under tension without moving through a range of motion. The plank is the most accessible example. You're not swinging weights. You're not grinding through reps. You're simply creating sustained tension across your entire kinetic chain. Your core, your shoulders, your hips, your fascia, and holding it. That sustained tension is one of the most powerful signals the body receives to produce collagen in the surrounding connective tissue. And because the joints aren't moving, the risk of irritation or injury is dramatically reduced. The second is eccentric loading. This is the phase of an exercise where the muscle is lengthening under load, the controlled lowering phase that most people rush through without thinking. In a push-up, it's the slow descent to the floor. In a pull-up, it's the deliberate lowering back to a dead hang. In a squat, it's the controlled drop before the drive back up. Research on eccentric training consistently shows it produces significantly greater collagen synthesis than concentric-only movement. The tension created during lengthening is uniquely stimulating to the fibroblasts in tendons and ligaments. In fact, some physical therapy protocols for tendon repair rely almost exclusively on eccentric exercises, because the evidence for their effectiveness in rebuilding collagen-rich tissue is that strong. So if you take nothing else from this section, slow down the lowering phase of every exercise you do. That simple change, applied consistently, will do more for your connective tissue health over the next 12 months than almost any supplement on the market. The third modality is sprint training, but approached with patience and strategy. Short, maximal effort sprints place enormous mechanical demand on the entire musculoskeletal system simultaneously. The fascia surrounding every major muscle group, the tendons in the ankles and knees and hips, the connective tissue around the heart and major vessels, all of it is loaded intensely in a very short window. This creates a powerful adaptive signal. Reinforce everything. But, and this is critical, sprint training after 40 requires a gradual progressive introduction. The connective tissue adapts more slowly than muscle tissue. If you go from sedentary to sprinting at full intensity in a week, you will get injured. The muscle gets strong before the tendon catches up, and that gap is where injuries live. The smart approach is to begin with short, controlled accelerations at 60 to 70% effort on a soft surface, progressively increasing intensity over weeks and months, giving the collagen synthesis process time to keep pace with the muscular adaptations. Now I want to address something that often gets overlooked in these conversations about exercise and aging: protein quality. You can train with intelligence and consistency and still undermine the entire process with the wrong nutritional inputs, because collagen synthesis requires amino acids, specifically glycine, proline, and hydroxyproline, and the quality of the protein you eat determines whether those building blocks are available in sufficient quantity. Plant-based protein isolates ultra-lean proteins like boneless, skinless chicken breast consumed in isolation, and processed protein supplements generally provide an incomplete amino acid profile for collagen synthesis. Grass-fed, grass-finished beef is one of the most complete sources. It provides the full amino acid spectrum along with a favorable omega-3 to omega-6 ratio that reduces systemic inflammation, which is itself a collagen-degrading force. The omega-6 to omega-3 imbalance that comes from relying heavily on conventionally raised chicken, pork, and processed protein sources quietly promotes the inflammatory environment that accelerates tissue breakdown. This isn't about being dogmatic about what you eat. It's about understanding that the quality of your raw materials determines the quality of what gets built. And then there is autophagy, the body's own cellular recycling system. The word comes from the Greek for self-eating. And while that sounds alarming, it's one of the most important regenerative processes in human biology. During autophagy, the body identifies damaged, misfolded, or dysfunctional proteins, including degraded collagen fragments, and breaks them down, recycles the components, and uses them to build new functional proteins. The most reliable way to activate autophagy is to stop eating constantly. Intermittent fasting, whether that's a compressed eating window, 2 meals per day, or periodic extended fasts, creates the metabolic conditions under which autophagy becomes highly active. The body, deprived of constant incoming fuel, turns inward. It begins housekeeping. It clears the cellular debris that accumulates with age and replaces it with new functional structures. This is not a diet trend. It is ancient biology. And for adults over 40, who are accumulating cellular damage faster than at any previous point in their lives. Creating regular windows for this process to occur is one of the most powerful anti-aging interventions available. No prescription required. Block 5, the silent accelerant. Stress, sleep, and the biology of decay. I want to ask you something personal, and I want you to actually answer it. Not out loud, but to yourself honestly. How well are you sleeping? Not how many hours you're technically in bed. Not whether you have a good mattress or blackout curtains or a white noise machine. I mean, when you wake up in the morning, do you feel like you've actually recovered? Do you feel like your body had the time and the resources to do what it needed to do while you were unconscious? For most people over 40, the honest answer is no, and that answer is costing them in ways they don't fully see yet. Sleep is not passive. It is the most anabolically active period in your entire day. It is when your body produces the majority of its growth hormone, when it repairs damaged DNA, when it consolidates memory, regulates immune function, clears metabolic waste from the brain through a system called the glymphatic network, and critically, for everything we've been discussing, synthesizes new collagen to replace what was broken down during the demands of the day. When you cut sleep short, when you sleep poorly, when your sleep architecture is disrupted by stress or alcohol or late-night screens or any of the 100 other modern intrusions on rest, you are directly undermining every other effort you make toward longevity. The training, the nutrition, the supplements, all of it operates at a fraction of its potential effectiveness when sleep is compromised. And the mechanism behind much of this damage is cortisol. Cortisol is your primary stress hormone. In appropriate doses at appropriate times, it is essential. It wakes you up in the morning, sharpens your focus under acute pressure, mobilizes energy when you need it. But cortisol was designed for short, intense threats, the kind that our ancestors faced and then resolved. A predator, a physical confrontation, a sudden danger that required everything the body had, briefly, and then passed. What cortisol was not designed for is the chronic low-grade relentless pressure that defines modern life for most adults over 40. The deadlines that never end. The financial anxiety that hums at a low frequency in the background of everything. The relationship tensions. The health fears. The constant overstimulation of a world that never fully powers down. That kind of stress keeps cortisol elevated not for minutes, but for hours, days, years, and elevated cortisol, sustained chronically, is one of the most destructive forces in the human body. It suppresses immune function. It disrupts blood sugar regulation. It interferes with thyroid hormone conversion. It promotes the accumulation of visceral fat, the deep abdominal fat that wraps around your organs and drives systemic inflammation. And directly relevant to everything we've been discussing, it massively accelerates the breakdown of collagen. Cortisol activates the very enzyme that dismantles connective tissue. It is, biochemically speaking, the molecular equivalent of pulling apart the cables of that bridge we talked about at the beginning. Here is the cruel irony that nobody talks about enough. The people who are most driven, most high-achieving, most committed to performing at a high level, they are often the ones most chronically bathed in cortisol. They push through fatigue. They skip recovery. They interpret rest as weakness or laziness. And their bodies pay the price quietly, invisibly, until one day it becomes visible all at once. You've seen it. Someone you know who aged dramatically in a short period after a particularly stressful chapter of their life. A divorce. A difficult period at work. A loss. The stress didn't just affect how they felt emotionally. It showed up on their face, in their posture, in the way they moved. That is cortisol doing what cortisol does when it runs unchecked. But here's what I want you to understand. This is not inevitable. And this is not about eliminating stress. That's neither possible nor desirable. Stress in controlled doses is the stimulus for growth. The goal is not zero stress. The goal is stress that has an off switch. Recovery that is real. A nervous system that knows how to downshift. Now, the science on this has gotten remarkably sophisticated in recent years, and I want to walk you through some of what we're learning about the biological clock, because it reframes everything. Your cells don't just age randomly. There is a measurable, trackable biological age that is distinct from your chronological age, the number of years since you were born. Researchers have developed what are called epigenetic clocks, most famously the Horvath clock, which measures specific chemical modifications to your DNA, called methylation patterns, that change in predictable ways as you age. These clocks can tell you not just how old your body is, but how fast it's aging relative to the average. And what these clocks consistently show is that chronic stress, poor sleep, high inflammatory load, and poor metabolic health accelerate biological aging dramatically. People with these risk factors can have a biological age 10 or 15 years older than their chronological age. Conversely, people who manage stress effectively, sleep deeply, eat in ways that support metabolic health, and move their bodies consistently can have a biological age significantly younger than their birth certificate suggests. This is not theory. This has been measured, replicated, and published in some of the most respected scientific journals in the world. What makes it even more remarkable is that epigenetic changes, unlike genetic mutations, are largely reversible. The methylation patterns that indicate accelerated aging can, under the right conditions, be shifted back toward a younger profile. Researchers call this epigenetic reprogramming. And while the most aggressive forms of it are still in experimental stages involving proteins called Yamanaka factors, which have shown the ability to push cells back toward a more youthful state in animal models, the lifestyle interventions that influence epigenetic age are available to you right now, today, without a prescription or a laboratory. Sleep is one of the most powerful epigenetic regulators we know of. Consistent, high-quality sleep actively shifts methylation patterns toward a younger biological profile. This isn't a metaphor for sleep makes you feel better. It is a measurable molecular reversal of the biological aging process. This means that every night you choose to prioritize real, deep, uninterrupted sleep over one more episode of television or one more hour of anxious scrolling. You're making a decision at the level of your DNA, a decision that either accelerates or decelerates the pace at which your body ages. That reframing matters, because most people make decisions about sleep based on how they feel in the moment. I'm not that tired, I'll catch up on the weekend. But if you understood that each compromised night is a measurable push forward on your biological clock, and that consistently good nights are a measurable pull backward, the calculation changes entirely. And the same logic applies to stress management. Not because stress is bad for you in some vague wellness magazine sense, but because the cortisol cascade it triggers is a direct, documented, epigenetically active force that ages your tissue, degrades your collagen, and advances your biological clock. Managing it isn't soft, it isn't optional. It is as fundamental to your longevity as anything you eat or any exercise you do. So what does effective stress management actually look like at the biological level? Not the surface level advice. Breathe deeply, take a bath, go for a walk. But the deeper mechanisms that genuinely shift the body out of sympathetic overdrive and into the parasympathetic state where repair and regeneration actually occur. That's exactly where we're going next. There's a nerve running through your body that most people have never heard of. And yet, it may be one of the most important structures in determining how fast you age, how well you sleep, how resilient you are to stress, and how deeply connected you feel to the world around you. It's called the vagus nerve. It runs from your brainstem all the way down through your chest, past your heart, into your abdomen, touching nearly every major organ along the way. It is the primary communication highway of your parasympathetic nervous system, the biological infrastructure of calm, of recovery, of regeneration. And here's what's remarkable. It doesn't just carry signals from the brain down to the body. Approximately 80% of the information traveling through the vagus nerve flows in the opposite direction, from the gut upward to the brain. Which means your gut is not just digesting food, it is actively talking to your brain, constantly, in a language made of neurotransmitters, hormones, and microbial metabolites that influence everything from your mood and stress response to your inflammatory levels and your biological age. This is not alternative medicine. This is one of the most rapidly expanding areas of mainstream neuroscience and gastroenterology. And what researchers are finding is fundamentally changing how we think about aging, mental health, and longevity. Let me give you a specific example, one that connects everything we've been building toward in this conversation. There is a microorganism, a specific strain of bacteria called Lactobacillus reuteri. It's been part of the human gut microbiome for thousands of years, but somewhere in the transition to modern life, the processed food, the antibiotics, the chronic stress, the dietary impoverishment, many people have lost it entirely from their gut flora. And researchers studying this particular microbe have found something extraordinary. When L. reuteri is present in sufficient quantities in the gut, it produces compounds that travel up the vagus nerve and stimulate the hypothalamus, a region deep in the brain, to release oxytocin. Not in the small transient pulses associated with social interaction, but in sustained, meaningful quantities that affect physiology throughout the body. Now, oxytocin is almost universally known as the bonding hormone, the thing released during hugs, during moments of deep connection, during intimacy. And yes, it does all of that. But the clinical picture of oxytocin is far more expansive than its popular reputation suggests. Oxytocin is one of the most potent anti-stress hormones in human biology. It directly suppresses cortisol. It activates the parasympathetic nervous system. It promotes deep restorative sleep. It reduces systemic inflammation. It accelerates wound healing. And in animal studies, particularly in work done at MIT and published in peer-reviewed journals, adequate oxytocin levels have been shown to restore muscle mass, improve skin thickness and texture, increase bone density, and extend healthy lifespan. In other words, oxytocin is doing things that we typically associate with youth, with vitality, with the biological state of a body that is repairing itself rather than simply deteriorating. And we may be able to restore it through the gut. The practical protocol that has emerged from this research involves culturing L. reuteri, a specific strain, ATCC PTA6475 for those who want to look it up, in a fermented dairy medium and consuming roughly half a cup daily. The fermentation process allows the bacteria to reach concentrations that are orders of magnitude higher than what you'd find in a commercial probiotic capsule. High enough, apparently, to meaningfully colonize the gut and sustain that vagal signaling to the hypothalamus. The results people report, and that researchers are beginning to document, include dramatically improved sleep quality, reduced anxiety, faster recovery from physical exertion, and visible changes in skin quality and muscle tone. All of it running through that single biological thread: the gut, the vagus nerve, and oxytocin. Now, I want to zoom out for a moment, because what this represents is something larger than one specific protocol involving one specific bacteria. It represents a fundamental shift in how we understand aging itself. For decades, the dominant model of aging was essentially a story of passive deterioration. You are born, you peak somewhere in your 20s or 30s, and then, gradually, inevitably, you decline. The machinery runs down, the parts wear out, and there's not much to be done except slow the pace of the inevitable. But the emerging science tells a radically different story. Aging, it turns out, is not simply a passive wearing down. It is, to a significant degree, a regulated process, driven by biological signals, epigenetic switches, hormonal environments, and microbial ecosystems that are far more malleable than we ever thought. The rate at which you age is not fixed, it is responsive. It is, in meaningful ways, a reflection of the inputs your body is receiving on a daily basis. This is why the centenarian research coming out of institutions like Albert Einstein College of Medicine is so compelling. When scientists study people who live to 95, 100, 105 years old, not just alive but genuinely healthy, sharp, mobile, engaged, they find something consistent and surprising. These people are not just lucky, they carry specific genetic variants that keep their inflammatory pathways quieter, their cellular repair mechanisms more active, their insulin sensitivity more robust. Their biology has found a way to stay in a state that resembles, at the molecular level, a much younger organism. And the question that researchers are now asking is not why are they so fortunate, but can we replicate what their genes are doing through other means? The answer increasingly appears to be yes, not through magic, not through some billion-dollar pharmaceutical that will make headlines in 30 years, but through the intelligent, consistent application of what we already know about sleep, about stress, about nutrition, about movement, about the microbiome, about the epigenome, applied with the seriousness and the discipline that the goal actually deserves. Because here's the thing about longevity that nobody says plainly enough. It is not a passive inheritance. It is an active practice, and you're either practicing it or you're not. Every single day, the choices you make are either advancing your biological clock or pulling it back. Not dramatically, not all at once, but steadily, cumulatively, in one direction or the other. The people who age well are not the people who got lucky. They are the people who at some point decided to take this seriously, who learned the mechanisms, who built the habits, who chose day after day to give their biology what it needs to function the way it was designed to function. That decision can happen at any age, including right now. Before I go any further, and I promise what's coming next is some of the most important information in this entire video, I need to pause for just a second. If you've made it this far with me, you're not the kind of person who watches the first 2 minutes of something and moves on. You're someone who actually wants to understand this, who takes their health seriously enough to sit with the complexity of it. And honestly, that puts you in a very small minority. We're getting close to a milestone that genuinely matters for this channel. And if what we've been discussing today has been useful to you, if even one thing has shifted the way you think about how you're aging and what you can actually do about it, I'd like to ask you something simple. Subscribe, hit that button, turn on notifications, and come back tomorrow. Because this is what we do here, every single day. We go deep. We don't simplify things to the point of uselessness, and we don't sensationalize things to the point of dishonesty. Every protocol on this channel is reviewed by a clinical pharmacist and researcher. That's not a marketing line. That's a commitment to you, that what you hear here is grounded in real science, not in whatever happens to be trending. If you know someone over 40 who's been feeling like their body is aging faster than it should, a friend, a partner, a sibling, share this with them. The information we're covering today is the kind that genuinely changes trajectories, and most people never hear it. Now, back to something that should genuinely change the way you see what's possible. Because here's the question I haven't answered yet. And it's the one that's probably been sitting in the back of your mind this entire time. Can aging actually be reversed? Or are we just slowing down something that's already been decided? The answer is more extraordinary than most people are prepared to hear. Let's start with what we know about the biological clock. Not as a metaphor, but as a measurable molecular reality. Researchers at institutions from Harvard to the Salk Institute have demonstrated something that would have been considered science fiction 20 years ago. The epigenetic markers of aging, the specific chemical modifications to your DNA that accumulate over time and drive cellular dysfunction, can be reset. Not slowed, not stabilized. Reset. The most dramatic demonstration of this comes from work with what are called Yamanaka factors, 4 specific proteins that, when introduced into aged cells, reprogram the epigenome back toward a younger state. The cells don't just behave younger, they measure younger. Their gene expression patterns, their metabolic activity, their structural integrity, all of it shifts back toward a profile that matches cells from a significantly younger organism. In animal studies, this has been done not just in isolated cells in a dish, but in living organisms. Aged mice treated with partial Yamanaka factor reprogramming showed measurable reversal of tissue aging in the eye, the kidney, the brain. Their biological age, as measured by epigenetic clocks, decreased. They didn't just stop aging forward, they moved backward. Now, full genetic reprogramming in humans is still years away from clinical application. The risks are significant. Push the reprogramming too far, and you risk cells losing their identity entirely, which is a path toward cancer. The current research is focused on finding the precise dose, the precise window, the precise combination that achieves rejuvenation without instability. But here is what makes this relevant to you right now today, without waiting for a pharmaceutical breakthrough. The lifestyle interventions we've been discussing throughout this conversation, the sleep, the stress management, the nutrition, the movement, the gut microbiome work, all of them influence the epigenome. All of them shift methylation patterns. All of them move the biological clock. Not as dramatically as direct genetic reprogramming, but in the same direction, through overlapping mechanisms, with effects that are cumulative and compounding over time. This is not speculation. Researchers using epigenetic clocks have measured the biological age of people before and after implementing structured lifestyle interventions. Improved sleep, anti-inflammatory nutrition, regular exercise, stress reduction practices, and documented measurable decreases in biological age over periods as short as 8 weeks. The Horvath clock, the Grimmage clock, the Dunedin pace, multiple independent measurement tools confirm the same thing. The right inputs, applied consistently, push the biological clock backward. Think about what that actually means. You are not a passive observer of your own aging. You are an active participant in it. The daily decisions you make, what you eat, how you move, how you sleep, how you manage the stress load of your life, are not just affecting how you feel today. They are chemically modifying your DNA in ways that either accelerate or decelerate the rate at which every cell in your body ages. That is simultaneously the most empowering and the most sobering thing I can tell you. Empowering because it means the trajectory is not fixed. You can change it. The science says so. Sobering because it means that every day of neglect, every chronically short night of sleep, every meal built around ultra-processed starches, every year of unmanaged chronic stress is leaving a measurable mark at the molecular level. Not just in how you feel, but in how your cells function, how your tissues repair, how long and how well you're going to live. Now let's talk about something that exists not in the future but on pharmacy shelves right now. Drugs that are generating enormous scientific interest for their apparent ability to slow biological aging in ways that go far beyond their original indications. The first is metformin. Originally developed as a treatment for type 2 diabetes, metformin has been observed to do something unexpected in long-term users. It appears to reduce the incidence of age-related diseases, including certain cancers, cardiovascular disease, and neurodegenerative conditions, at rates that exceed what would be predicted by its blood sugar effects alone. Large-scale epidemiological studies have shown that diabetics taking metformin outlive non-diabetic control groups who were not on the drug. That finding was striking enough to launch a major clinical trial, the TAME trial, targeting aging with metformin, specifically designed to evaluate whether metformin can slow aging itself as a primary outcome. The mechanism appears to involve metformin's ability to activate AMPK, an enzyme that functions as a cellular energy sensor and master regulator of metabolic function. When AMPK is activated, it mimics many of the effects of caloric restriction, the most robustly documented life extension intervention in biology. It reduces inflammation, promotes autophagy, improves mitochondrial function, and sensitizes cells to insulin, all processes that deteriorate with age and that drive the diseases of aging. The second is rapamycin. Originally developed as an immunosuppressant for organ transplant patients, rapamycin has become perhaps the most discussed longevity drug in serious scientific circles. It works by inhibiting a protein complex called mTOR, the mechanistic target of rapamycin, which is one of the central regulators of cellular growth, metabolism, and aging. When mTOR is chronically elevated, as it tends to be in environments of nutritional excess and low physical stress, cells prioritize growth over maintenance. Autophagy slows. Cellular garbage accumulates. Senescent cells persist. The machinery ages. Rapamycin, by suppressing mTOR, shifts the cellular priority back toward maintenance, repair, and quality control. In virtually every organism it has been tested in, yeast, worms, flies, mice, rapamycin extends both lifespan and health span. In mice, it has extended maximum lifespan even when begun late in life. The equivalent, in human terms, would be starting an intervention at age 60 and still seeing meaningful results. Bloco 8. Senescence, inflammation, and the cells that are silently aging you. There is something happening inside your body right now that nobody warned you about. Something that has no symptoms you can feel directly, no visible sign you can point to in the mirror. But that is according to some of the most respected researchers in geroscience. One of the primary drivers of aging and age-related disease. It's called cellular senescence. And understanding it might be one of the most important things you do for your long-term health. Here's what happens. Throughout your life, your cells divide. They copy themselves, replace damaged or worn-out cells, and maintain the tissues and organs that keep you alive. But cells are not designed to divide indefinitely. After a certain number of divisions, or after sufficient damage from stress, radiation, toxins, or metabolic dysfunction, a cell reaches a point where it can no longer divide safely. At that point, it has two options. It can undergo apoptosis, which is a clean, programmed self-destruction that allows the body to recycle its components without causing damage. Or it can become senescent. A senescent cell doesn't die. It doesn't divide. It just sits there. Metabolically active, stubbornly persistent, and deeply disruptive to everything around it. And here's the problem. Senescent cells don't keep their dysfunction to themselves. They secrete a cocktail of inflammatory molecules, cytokines, proteases, growth factors, that researchers have collectively named the senescence-associated secretory phenotype, or SASP. This secretory profile actively degrades the surrounding tissue, recruits immune cells in ways that promote chronic inflammation, and, perhaps most troublingly, can push neighboring healthy cells towards senescence as well. It spreads, like a single rotten apple quietly corrupting the ones around it. In a young, healthy body, the immune system efficiently identifies and clears senescent cells before they can accumulate in significant numbers. But as we age, two things happen simultaneously. The rate at which cells become senescent increases, and the efficiency with which the immune system clears them decreases. The result is a slow but relentless accumulation of these inflammatory tissue-degrading cells in virtually every organ of the body. The brain, the heart, the joints, the skin, the lungs, the kidneys. Senescent cells accumulate everywhere, and their SASP activity drives the chronic low-grade systemic inflammation that underlies almost every major age-related disease, from cardiovascular disease and type 2 diabetes to neurodegeneration and cancer. Researchers have a term for this background inflammatory state, inflammaging, a portmanteau of inflammation and aging. And it is arguably the most important biological concept for anyone over 40 to understand, because it connects virtually everything we've discussed in this conversation into a single coherent framework. The sugar-driven glycation we talked about in the beginning, it drives inflammation. The collagen-degrading enzyme that accelerates when cortisol is chronically elevated. Inflammation activates it. The gut microbiome disruption that reduces oxytocin and compromises vagal tone. It correlates directly with increased systemic inflammatory markers. The poor sleep that fails to clear metabolic waste from the brain and disrupts hormonal repair cycles. It is both a cause and a consequence of elevated inflammation. Inflammaging is the common thread, the shared mechanism, the biological environment in which aging accelerates dramatically, and which, when addressed, allows the body to shift back toward a state of genuine repair and resilience. Now, there are emerging pharmacological approaches to this, a class of drugs called senolytics, which include combinations like dasatinib and quercetin, have shown the ability to selectively eliminate senescent cells in animal models, with results that are frankly remarkable. Animals treated with senolytics don't necessarily live dramatically longer, but they live dramatically healthier. Their physical function improves, their tissue quality improves, their inflammatory markers drop. The compression of morbidity, the idea of having a shorter, sharper decline at the very end of life rather than a long, slow deterioration, becomes measurable. Clinical trials in humans are underway. Early results are promising. But we are not yet at the point where senolytic therapy is a standard, widely available clinical intervention. What is available right now and what has meaningful evidence behind it as a senolytic adjacent intervention is something we've already discussed: intermittent fasting and autophagy activation. When the body enters a deeply autophagic state, typically requiring an extended fast of 16 hours or more, it becomes significantly more aggressive in identifying and clearing dysfunctional cellular material, including senescent cells. This is not as targeted or as potent as pharmaceutical senolytics, but it is a real measurable effect that costs nothing and requires no prescription. Exercise, particularly high-intensity interval training, has also been shown to reduce markers of cellular senescence and systemic inflammation. The mechanisms are multiple. Exercise activates anti-inflammatory pathways, promotes autophagy, improves immune surveillance, and reduces the accumulation of visceral fat, which is itself a significant source of pro-inflammatory cytokines. Quercetin, a flavonoid found in high concentrations in capers, red onions, and apples, has shown senolytic properties in cell culture and animal studies, and is available as a supplement without a prescription. And then there is the dietary dimension of inflammaging, which is both the most impactful and the most within your immediate control. The foods that drive systemic inflammation most powerfully are precisely the ones that dominate the modern Western diet. Refined seed oils high in omega-6 fatty acids, ultra-processed carbohydrates that spike blood glucose and drive glycation, processed meats treated with nitrates and other preservatives, and artificial additives that disrupt the gut microbiome. These are not foods that cause dramatic immediate harm. They are foods that create a slow, cumulative, invisible inflammatory burden that quietly ages every tissue in your body over years and decades. The foods that most reliably reduce systemic inflammation are, again, the ones we've already discussed: fatty fish rich in omega-3s, dark leafy greens, colorful vegetables packed with polyphenols, fermented foods that support microbiome diversity, extra virgin olive oil, one of the most extensively studied anti-inflammatory dietary components in existence, and high-quality animal proteins that provide complete amino acid profiles without the inflammatory omega-6 burden of conventionally raised, grain-fed livestock. This isn't a diet. It's a biological environment. You are either creating conditions in which your cells can repair themselves, clear their senescent neighbors, and maintain their functional integrity, or you are creating conditions in which the opposite happens. Every meal, every day. The accumulation is real. The direction is chosen. We've covered a lot of ground in this conversation, and I want to take a moment to acknowledge something. If you've been listening carefully, you may have noticed a pattern emerging, not just in the specific recommendations, but in the underlying logic that connects all of them. Because there is a logic. A coherent, elegant biological framework that ties together everything from collagen synthesis to cellular senescence to epigenetic reprogramming to oxytocin and the vagus nerve. And that framework is this. Your body has a default state of repair, not deterioration. Repair. The capacity to rebuild collagen, clear senescent cells, reset epigenetic markers, restore hormonal balance, regenerate gut microbiome diversity, and reverse measurable biological age. All of it is built into your biology. It is not something you have to add from the outside. It is something your body will do automatically, given the right conditions. What modern life has done, with its processed food, its chronic sleep disruption, its relentless low-grade stress, its sedentary defaults, and its pharmaceutical shortcuts, is systematically remove those conditions. Layer by layer, habit by habit, decade by decade, it has pulled the body away from its natural repair state and pushed it toward accelerated deterioration. The work of longevity, then, is not complicated in principle. It is simply the work of restoring conditions, of removing the inputs that drive dysfunction and replacing them with the inputs that enable repair, of getting out of your own body's way. Let me bring this into something concrete. A practical synthesis of everything we've discussed, not as a rigid prescription, but as a framework you can actually build a life around. Start with sleep, not as a luxury, not as something that gets the hours that are left over after everything else is done. Sleep is the foundation on which everything else rests. Without it, no other intervention reaches its potential. 7 to 9 hours of genuine, uninterrupted sleep in a dark, cool room with consistent timing, protected from screens and stimulants in the final 90 minutes before bed. This alone, done consistently, will shift your epigenetic age. It will restore growth hormone secretion. It will allow collagen synthesis to occur at the rate your body is capable of. It will reduce cortisol. It will support immune clearance of senescent cells. It is the single highest leverage intervention available to you, and it costs nothing. Layer in movement with intelligence. Daily movement as a baseline. Walking, which stimulates fascia, promotes lymphatic flow, reduces inflammatory markers, and supports metabolic health in ways that dedicated gym sessions cannot fully replace. 2 to 3 sessions per week of resistance training with an emphasis on eccentric loading and isometric holds. 1 to 2 sessions per week of higher intensity work, sprints, intervals, introduced gradually and progressed carefully, with full respect for the slower adaptation rate of connective tissue relative to muscle. The goal is not performance in the gym. The goal is a body that functions better at 60 than it did at 50 and better at 70 than it did at 60. Build your nutritional environment deliberately, not with perfection. Perfectionism around food creates its own cortisol burden, but with clarity about what your body actually needs. Adequate high-quality protein, grass-fed beef, wild-caught fish, eggs, organ meats to support collagen synthesis and muscle maintenance. Abundant, colorful vegetables and fermented foods to feed the microbiome and reduce inflammation. Consistent intake of the key cofactors: vitamin D3, vitamin K2, magnesium, zinc, copper, vitamin C from real food sources. Elimination or dramatic reduction of ultra-processed seed oils, refined starches, and foods that drive glycation and inflammation. A compressed eating window that creates regular autophagy activation, not as punishment, but as the simplest, most effective cellular housekeeping practice available to you. Manage the cortisol load seriously. This means identifying the chronic stresses in your life, not the acute ones which are unavoidable and even beneficial, but the chronic background stressors that keep your sympathetic nervous system locked in a low-grade state of alert, and building real practices that activate the parasympathetic counter-response. Breathwork, time in nature, physical touch and social connection. The L-Reuteri ferment that drives oxytocin production through the gut-vagus-brain axis. Whatever works for your nervous system specifically, but something. Because unmanaged chronic stress is, at the biological level, the fastest path to accelerated aging that exists. Protect your microbiome. Avoid unnecessary antibiotic exposure. Eat fermented foods daily: raw sauerkraut, kimchi, kefir, yogurt. Prioritize dietary fiber from diverse plant sources to feed the microbial ecosystems that regulate your immune function, your inflammatory tone, your neurotransmitter production, and your ability to generate the hormonal signals that keep your body in a state of repair. Consider targeted probiotic supplementation, particularly L-Reuteri in the cultured form we discussed, as a specific intervention for oxytocin, sleep quality, and systemic anti-aging effects. Track what matters, not obsessively, but intelligently. Your biological age, through epigenetic testing, is now commercially available and can tell you with remarkable precision how the choices you're making are affecting the pace of your aging. Inflammatory markers, hsCRP, IL-6, are standard blood tests that tell you whether your internal environment is trending toward repair or deterioration. Fasting insulin, HbA1c, and glucose variability tell you about your metabolic health, which is one of the strongest predictors of biological age. Testosterone and other hormonal markers, particularly in men over 45, tell you whether the hormonal environment supports muscle maintenance, cognitive function, and the drive that makes all of the above sustainable. And this is the part that gets left out of most conversations about longevity, build something worth living for. Because the research on centenarians consistently shows something that no protocol and no supplement can replicate. The people who live longest and best are the people who have reasons to, who have purpose, who are embedded in genuine community, who feel that what they do matters to people they love. The Okinawan concept of ikigai, a reason for getting up in the morning, shows up in the longevity data as clearly as any biomarker. The social isolation that is epidemic among adults over 60 in the developed world is not just emotionally painful, it is biologically aging. It elevates cortisol, reduces oxytocin, increases inflammatory markers, and shortens life. Connection is not separate from the biology of longevity. It is part of it. This is the full picture, not a simple list, not a 10-step plan. A way of understanding your body, its needs, its capacities, its remarkable resilience when given the conditions it requires, that makes every individual choice feel less like discipline and more like respect. Respect for the extraordinary biological machinery you were given, and for the life it makes possible. We've been talking for a while now, and if you're still here, I think you already know why. It wasn't really about collagen, or senolytics, or the vagus nerve, or even the epigenetic clock and the remarkable documented possibility that your biological age can move backward. It was about something underneath all of that, something you recognized somewhere in the first few minutes and have been sitting with ever since. The feeling that more is possible than you've been told, than you've been allowing yourself to believe. Because here's what I've observed, not just in the research, but in the way people respond when they actually understand this material. The information itself does something. It changes the relationship, not with supplements or protocols or any specific intervention. The relationship with your own body. When you stop seeing your body as something that is happening to you, declining, deteriorating, betraying you with every new ache and every new line, and start seeing it as something you are in a genuine, ongoing conversation with, something that is responsive, that is listening, that will meet you more than halfway if you give it what it actually needs, everything shifts. The choices become different, not harder, different, because they come from a different place. Not from fear of what's coming, but from respect for what's already here and genuine curiosity about what's possible. That is the quietest and most important thing I can leave you with today. The biology is real. The science is solid. The protocols work. But none of it works in a body whose owner has given up on it. None of it works in a life where health is something you do as penance rather than something you do as an expression of what you value. The people who reverse their biological age are not the most disciplined. They are the most convinced. Convinced that it matters. Convinced that they are worth the investment. Convinced that the years ahead can be genuinely different from the years that are behind. Not a slow diminishment, but a deepening. A continued becoming. That conviction is not something I can give you. But perhaps today, some of what we discussed has made it slightly easier to find it in yourself. You don't have to do everything at once. You don't have to be perfect. You have to start. And then you have to be consistent. And then you have to trust the biology. Because the biology, when you stop working against it and start working with it, is extraordinarily capable of doing exactly what it was designed to do. Repair, regenerate, persist. One last thing. If this conversation changed something for you, if it gave you a framework you didn't have before, or named something you felt but couldn't articulate, do something with it. Don't let it sit in a browser tab and fade. Share this video with 5 people who need to hear it. Not people who are already obsessed with longevity and biohacking. The people in your life who are quietly accepting a decline they don't have to accept. The ones who are too busy, too tired, too discouraged to seek this out on their own. Send it to them. That small act might matter more than you think. Subscribe to this channel if you haven't already. We do this every day. Real science reviewed by a clinical pharmacist and researcher, translated into information you can actually use. No hype, no shortcuts, just the work. And leave a comment below, a real one. Tell me what landed for you today. Tell me what shifted, and tell me, what do you want us to go deep on next? Your question might become the next video, and it might be exactly what someone else needed to hear. The clock is running, but now you know it can also run the other way.